this video we have learning about the Fourier transformation, and in today's video we are going to learn how to find the Fourier transform of a cos time domain graph. So here, as you can see, xt is equals to cos 2 pi fct, and now we are going to use the Fourier transform equation and going to change from the time domain to frequency domain. And if you are new to this expert tutorial channel, don't forget to subscribe. And also we have already done many videos regarding Fourier transform. If you haven't watched those videos, I have given the link in the description, so you can always watch that. So first of all, you need to understand, even if they are asking any type of equation, if they are giving any type of equation, and if they are asking the Fourier transform of those, just what you need to do is you need to write the equation of the Fourier transformation directly. That's the only thing you need to do. So now I have written the Fourier transform equation xf is equal to from xt into e to the power minus 2 pi j ft, and we need to integrate from minus infinity to plus infinity. And after that, what I'm going to do is I'm going to substitute this cos 2 pi fct towards xt. Now what we can do, since there are two variables which is going to be two variables in the sense means that we are having cos 2 pi fct one section and the portion e to the power minus 2 pi jft, which means there are two types. So how you can do this? Either you can do it in two methods. You can use the part by integration method 2 times and you can directly get the answer, or else you can simply do this by transforming this cos theta into a complex form, which we have already learned in our previous video. So if you haven't watched those videos, please just go and watch that first. So in our previous video, we have learned that cos theta is equals to e to the power j theta plus e to the power minus j theta divided by 2. So here also we are going to write it in that manner so that we can easily figure it out, the integration of this part. Now what I have done is I have just cross multiply inside these brackets, and what we are going to get is e to the power minus 2 by j. If we multiply these two, we are going to get e to the power minus 2 by j into f minus fc into t plus. If you multiply these two, you are going to get like this. So now we are having these two in two e to the power functions. So now what we can do is we can directly separate, since there is a plus. So if you separate these two parts, you are going to get like this. So can you see some similarity of this function to the previous function you have studied? Actually, we have learned that if there is a function called 1, and if you want to change this function to another Fourier transformation, which means if you are like to change this one to the Fourier transform Fourier frequency domain, what we will normally do is we will multiply by 2 pi j f into t dt. If we do so, we are going to get a direct delta function, which we have learned in the previous video. It's going to be delta f, which means we are going to get at this frequency when the frequency is 0. So this is we already learned in our previous video. Can you see some similarity between this one and this one? Instead of f, there is f minus fc. So can you understand what's going to happen over here? So instead of f, what's going to happen if you do this? You are going to get the direct delta function, but now the point is different. Instead of f, it's going to be f minus fc. Likewise, if you do to this one, you are going to get, instead of f, you are having f plus fc. So that's the important thing. So the Fourier transformation of a cos function is going to be direct delta function, but there are two direct delta function with the amplitude half, and also the position is different. Notice when the f is equal to 0, here it has shifted. One is f minus fc and another one is f plus fc. This is going to be like this. I hope now you are having some sort of an idea how this works. And another important thing is, you might think that why can't we use the direct integration for doing this one without using this direct delta functions equation. So the thing is, if you are using the direct integration for this, you are going to get an indefinite form, which means you are going to get infinity and minus infinity, and you are going to get a complex form which you need mathematics to solve that. Instead of that, in our previous video we have learned that how we have came to a decision that the function of xt, when that xt is equals to 1, the Fourier transform of that xt is going to be direct delta function. By using that technique or that idea or that definition, we have just get this one. It's going to be like this. So actually you can easily get the idea from this. Here you can see the frequency of that cos wave. So when you are doing the Fourier transformation, as we already learned, which means it's going to give the same graph or the same wave in the frequency domain, which means here you can see the frequency is going to be fc. For other frequency it's 0. Likewise, here is the minus fc, which means always remember that it's actually giving the actual frequency of this of this cos wave. So that's the thing you can easily express from this Fourier transform by using Fourier transform for cos wave. I hope now you are having some idea, and if you are having any doubts, please comment below. Thank you for watching.